The main roller structure will be made from this 40 by 40 mm square steel tube with 3 mm sidewall, measured and cut pieces with 145 and 180 mm length. Now it is time for a bit of measuring, marking and drilling some holes. First I found the middle of the tube and then marked 3 places for vertical holes. Those 3 will be drilled on both steel tube pieces identically. Also, all holes will be drilled all the way through. Next I flipped the piece by 90 degrees and drew the line with 13.5 mm offset from the tube side. Here I marked a pair of places for horizontal holes. Later on you will see why such an offset is necessary. In a local hardware store I bought this I-wood screw. Not sure about the purpose it was made for, but I need just that round part, which is exactly 12 mm in diameter. Also, I will use a piece of this M12 threaded rod, which I had from some previous projects. I don't like how the bottom part looks, so I marked and cut both sides in angle. Metal rods on both sides will be acting as sliders, while the middle one will be generating the pressing power. The best way to fix them permanently is to weld them. After the welding, I flattened the surface, because this tool will be attachable to the workbench and must have a flat bottom. Press like and subscribe buttons if you like my content. Your support encourages me to keep working on new projects. For rollers, I'll use this kind of bearings. They are very cheap and are the perfect size for this project. 37 by 12 by 12 millimeters. And I will use 9 of them. Each roller will be formed from 3 bearings and attached to the M12 hex bolt and nut. Do you remember that 13.5 mm offset when I was marking the center for this hole? Here is the answer for such measurement. I no need to hold the nut with any tool, because the steel tube sidewall is doing it for me. With an upper roller, the situation is a bit different. All bearings should be attached with a bolt, but at the same time I need to spin the outer bearing part with some kind of handle. So I need to fix the outer part in one piece and will have a place where I could mount a handle. And here's the solution. Old pistons from car brake calipers. In my metal scrap box I found these 3. They are round, they are closed on one side, and this one has almost 37 mm of inner diameter, which means I could press all 3 bearings inside nice and tight. Before pressing bearings in, I need to drill a few holes. One in the middle for the main bolt, which attaches bearings in place, and 4 holes on the perimeter to attach the handle. Those 4 holes also were tapped for M5 machine screws. All 3 bearings were pressed nicely with a vise. The handle will be made from this 5 by 40 mm steel flat bar. When all holes were drilled and the outer form was shaped, I need to make the final step, to form a small offset that clears enough space for 2 bottom rollers. The upper roller was attached as the 2 in the bottom, with an M12 hex bolt and nut. The handle will be held by 4 M5 machine screws. And lastly, the handle was finished with M12 hex bolt, a piece of PVC pipe, and a pair of nuts. This roller bender could be attached to any flat workbench with a pair of clamps. More pressure you will apply with the nut, faster workpiece will bend. You could manage to bend just a bit to an arc or go all the way to the full circle. The design is minimalistic as possible, so if you need to bend bigger and thicker pieces, there is no problem to scale it up. I started with this mild steel U-shaped metal beam leftover. It is 14 cm in width and 6 cm in height. Measured and cut 26 cm, which will be the total length of the vise. Next, trim both sides to lower it from 6 cm to 2.5 cm in height. To get a perfectly straight and level cut, I used this homemade attachment for the angle grinder. Few bearings, bolts and square tube converts this angle grinder to a rolling cutting machine. Of course, those cuts could be made by hand, but I wanted to try this jig in this build, and it performed extremely well. A single cut left a very nice and perfectly straight edge. I drilled 2 38mm holes in both ends and with an angle grinder connected those to form a nice 38mm slot. On both sides, I marked, drilled and tapped M10 holes. Here I want to make the vise a bit wider. I used 25 by 25mm angle iron pieces with drilled representing holes. This will extend the vise bottom, which mostly will be used as a clamping surface. A bit of grinding was needed to make the whole surface perfectly flat. The very last modification on this base was to drill and tap 4 holes in corners for M12 Allen bolts. Did you remember that offcut? I will use it and cut a pair of angle iron pieces for the Wice jaws. It not only helped to get the best use of the U-shaped metal beam, but it has a very nice shape also. I managed to get only 2 pieces from that leftover, so the third one I cut from a regular angle iron found in my metal scrap. Here you could see that angle iron shape differences. The bottom part is thicker than a vertical one, which I like a lot. 2 angle iron pieces placed at the base ends will be secured permanently, while the middle one should be moved freely. The process here is the same as in all connection points in this build, drilling a pair of holes in each part to secure it with M12 Allen bolts. This angle iron is way too thin for my planned application, so I make it thicker by adding this 10 mm of thickness flat steel strip. As the inner corner has some radius, I need to trim that steel strip bottom respectively to get that perfect fit. Angle iron was drilled and tapped to make mounting points for the reinforcing steel strip. A pair of M10 Allen bolts secure them to one solid piece. Here is the answer why such thickness was needed. In this place, I will use an M20 threaded rod as the main Wice screw. This is a good example of how to drill holes in strangely shaped metal parts without a drill press vise. A simple support piece made from scrap wood and a clamp did the job. By looking at the thread, it looks like one solid piece. As I like to make stuff not only functional but at the same time looking neat, I modified both sandwiched parts to a more lightweight and aesthetic look. The smaller part gave the idea of how the angle iron should be trimmed too. Now both parts could be fixed permanently. To keep the sliding jaw moving freely along the slot, I will sandwich it with those 2 metal pieces. After drilling and tapping, all parts could be bolted together. And it slides way better than I expected. Very nice. To keep moving the sliding jaw, I used an M20 threaded rod. Here I have to pay the price of using that nice shape angle iron jaw. The bottom part is too thick for the M20 threaded rod. Not a big deal, I marked and grinded the needed groove with a rotary tool. It took a while, but now the threaded rod fits perfectly. To attach the threaded rod to the moving jaw, but at the same time let him spin freely, I used those 2 metal strips. First, I marked and grinded a groove on the rod with an angle grinder. Later on, I made a different size U-shape cut in each metal strip. Here is how it works. The part with the bigger slot will act as a spacer between the jaw and the end of the rod. The piece with the smaller slot will hold the threaded rod attached to the moving jaw and also let the rod turn freely, if it makes sense. When the holes were drilled and the parts mounted on the sliding jaw, I didn't like how it looked, so made small corrections. This time I modified only those two parts. I wanted to shape them in the same form at one time, so I bolted them together with a pair of Allen bolts while cutting and grinding them to the needed shape. Now it looks way better than before. Before attaching a threaded rod to the vise, I need to mount a handle. The perfect candidate is this 12mm diameter stainless steel rod. To join them together, some drilling and grinding were needed. The threaded rod got the hole and the slot in the middle. Meanwhile, the stainless steel handle was shaped to fit in that slot. To keep those two parts together, I used a pin made from a nail and flattened another nail end. Holds in place and the handle moves freely. Time to mount it into the vise. It spins very freely. Let's try it out on a drill press. This vise has enough holding power to hold not only square parts. The metal strip or round pipe makes no issues too. What I like a lot, that this vise is low profile, wide, quite heavy, and it could be used for all kinds of applications around the workshop. For example, I cut this metal strip without clamping the vise onto the workbench. During the cut, the vise moved just a hair, which saves me time instead of clamping it. Yes, I'm hearing you shouting, why make such thing if you could buy it for a decent price? Well, the reason is the same as with all other handmade tools. You use what you have, make it to fit your specific needs, including shape, size, and technical characteristics, and what is most important, enjoy by building it. I took this M14 coupling nut, which turns in a roller during the process. I planned to use some hardwood around the nut, but later on decided to glue a few pieces of the plywood to achieve the higher strength. 3 layers of 15mm plywood will be exactly the same height as the coupling nut. The miter saw, glue and clamps do the job, and the plywood brick was made. The outer roller shape was cut with a hole saw and the inner hole by using the Forstner bit with a centering template assistance. A strong hit with a hammer left precise shape and indication of how much plywood must be chiseled out to make a perfect fit. I use 5 minutes epoxy to glue the coupling nut inside the plywood roller. When the epoxy was rock solid, started to shape the needed roller form. First, I cleaned both ends. Second, used the angle grinder and a belt sander to make the roller perfectly round. And third, I found the middle of the roller and sanded down a slight angle from sides to the middle. This roller shape will act as self-adjusting belt guide and will keep the sanding belt in place. The roller is done, let's move on to the support structure. I used 25 by 25 mm square steel tube and cut 30 cm piece. By using angle grinder shaft as a reference point, found the ideal place where the square tube should be attached. Also marked how much the angle grinder guard should be trimmed to make enough space for all upcoming parts. The square tube will be attached with 2 M8 bolts, so I drilled 2 holes on the angle grinder guard and after that repeated that on the square tube. By drilling the smaller hole first, I got a better centering point for a bigger drill bit. This also made it easier to drill a larger hole. The square pipe center is a bit offset from the needed roller centering line, and it should be somewhere about here. So I used these 3 washers made from 3 mm steel to align the pipe and roller centers. Added one more custom cut steel washer under the nuts to spread both tightening force into a wider surface. The next moving part will be made from 20 by 20 mm square steel tube, which nicely fits inside the 20 mm square tube. To keep the sanding belt always tensioned, I'll use this spring under the smaller square tube. The spring sits on the first bolt, which can be said about the square tube. This spring should not get stuck into the pipe. Not a big deal, few cuts with the angle grinder, a bit of hammering, and the support surface were done. I'm planning to use this sanding belt, which is made for a regular belt sander. I already measured that the total length from one side to another should be 24 cm. Secured the metal ruler with a pair of magnets in place and marked a few reference lines with 1 cm spacing on the smaller tube. By compressing spring, I found that the perfect travel should be 1 cm. So I marked the place where the ruler shows 0 and added that additional centimeter for spring compression travel. Cut with the angle grinder on the mark to get the final length. One end of the smaller pipe will sit on the spring, while another one should keep sandpaper rolling. A pair of the small bearings will make it possible. I used 24 by 8 mm sized bearing with the 8 mm inner hole. The width of 2 bearings stacked together will fit perfectly inside this tube. Marked and drilled a hole for a bolt, which will secure bearings in place. After that, cut and trim the metal to get nice and tight slot for bearings. Some final shaping was made with the angle grinder and the belt sander. Added a very thin washer in between the square tube and the bearing to ensure that the bearing will not rub into the tube. As I mentioned before, I'm planning to use the regular belt sander sanding belts. As they are way too wide for this power file, I simply cut them into my preferred width. This one was cut to 3 cm width. This power file setup is capable to use from 16 to almost 40 mm with sanding belts. I spun the belt by hand to check if everything is straight and the shaped roller is keeping the belt aligned in the center. And looks it does. To blend in all fabricated parts to the angle grinder, I made a quick spray can paint job. Here's some test sanding on different materials. It is no matter if you need to clean a very rusted metal surface or to trim sharp metal edges. This power file makes this job very easy. Together with fast work, it also provides very precise grinding control. Talking about the wood, this beast eats it like butter. Hey, make sure to subscribe so you don't miss out on my future videos. Till the next time, bye.